Today, working with powers of trig functions first, and then we'll talk about equations of perpendicular bisectors. But for powers of trig functions, the whole thing is, what does the notation mean? We're going to start seeing things sine squared, sine cubed, tangent to the fourth. It does not mean that we take and square the angle. It does not mean the sine of theta squared. It means figure out what the sine of the angle is and then square that answer. So the only trick is knowing the notation on this. And we're going to go through several different examples where we get a little bit of practice with this. And that will also let us practice some of our reciprocal trig functions and unit circle values, which will be good practice since we have a test coming up tomorrow and you need to know everything about your unit circles to be able to answer some of the problems on that test. So we might get something like this. The sine cubed of -60. That means we need to figure out what is the sine of -60. And after we know that answer, cube it. So -60, which quadrant, everybody? Fourth. So we come down here. And if I need my unit circle here, I can draw it, and I can draw my triangles. So if I draw my triangle like that, this reference angle is going to be 60 degrees. So I need the sine for that. Help me out with that. What is the sine of -60? We need to get where we know these right away. If you take this long on the test tomorrow, you will run out of time. Abby, positive or negative? It will be -√3/2, which we will end up cubing. Now, since we're having trouble with that, let's review how we remember that if we are fuzzy on it. Normally, our reference triangle with a 30, 60, 90 triangle is 1 for the short leg, 2 for the hypotenuse, square root of 3 for the long leg. Since we are in fourth quadrant, horizontal is positive, vertical is negative, so I'm going to put a minus sign in front of that √3. To make it be the unit circle, I need my radius to be 1, so I divide by 2. And then we have also done enough of these that if we do sine, we are doing opposite over hypotenuse. So I take this vertical part over 1. So the sines are just the y coordinates, just the vertical parts. If I'm below the x-axis, the sine's negative. If I'm above the x-axis, the y-coordinate, the sign is positive. If I did -√3/2 over 1, I would simply have the -√3/2. But now I need to cube it. Negative, negative, negative is 3 negatives make a negative. √3, √3, √3 is regular 3 times √3. And 2 cubed is? So does that make sense to everybody? You evaluate it first, and then you cube it or square it or whatever. All right, next one. One of my reciprocal trig functions. Cotangent is what? It could be cosine over sine. It could also be, what was the other one I heard? 1 over tangent. Where we use cosine over sine for now is going to be if we're on the axes. Is 330 degrees going to be on one of the axes? So we might as well use 1 over tangent. Later on, we'll also use cosine over sine when we're proving trig identities. So for this one, we're just going to say it is 1 over the tangent of 330 degrees. And then we need to square whatever that answer is. So everybody with your arm, show me where is 330 degrees going to put us? So very good. Just a little bit into the fourth quadrant. So that highest one that's down there in the fourth quadrant. Do you remember what is the tangent when you are there? Okay, it is negative root 3 over 3. Remember, tangent is positive, negative, positive, negative. And in this quadrant, when we draw our 30, 60, 90 triangle, get that back up there in a minute. Short leg is 1, hypotenuse is 2, long leg is root 3. And then since it is in the fourth quadrant, horizontal is positive, vertical is negative. Tangent is opposite over adjacent, so negative 1 over root 3, or negative, if I multiply numerator and denominator by root 3, negative root 3 over 3. So I need 1 over that. So I'm going to go back to the 1 over the negative 1 over root 3. Could use it either way. Since I have 1 over, I'm taking the reciprocal. So I need to take this negative 1 over root 3 and turn it upside down. So it becomes negative root 3 over 1. And if I square that, negative root 3 times negative root 3 is regular 3. Questions with that one? Several details to keep track of with. On these kind of problems, you've got to keep track of a lot of little details. Okay, cosecant. 1 over what? So first thing I'm going to do is write that is 1 over the sine. Oh, radians now, pi over 3. And once I figure that out, I need to square it. So pi over 3 is which quadrant? First quadrant. The highest one of the lines that we have actually in the first quadrant. So that means this is a 60-degree angle, except we're not really going to label it with that. We're just going to think of it like that. Okay, who remembers what the sine is, the y-coordinate when we are there? Good, we're doing a lot better with that one. Root 3 over 2. So we have 1 over, the sine is root 3 over 2, and then we need to square that. Since it is 1 over, I'm going to turn this denominator upside down and say that is 2 over root 3. I'm not going to worry about rationalizing denominators till I get to the very end, because some of times like this one, they're going to go away. I'll rationalize at the very end if I still need to. 2 times 2 is root 3 is, and we're finished with that one. Let's do one more and then we'll switch over to the equations of lines. Secant, 1 over what? So we first write down that this is 1 over the cosine of minus 2 pi over 3, and then we need to cube all of that. So show me, where are we if we are at minus 2 pi over 3? Where does that put us? Okay, minus, we're going to go down, we're going to go in the clockwise direction. Pi over 3, 2 pi over 3, so we're in the third quadrant. Okay, cosine. That is my x-coordinate. How far to the left have I gone? Negative what for my cosine? What was that, Avery? Negative 1/2. So this is 1 over negative 1/2. And we need to cube it. Since it's a reciprocal, turn it upside down. And we have negative 2 over 1 that we need to cube. And what is negative 2 cubed? So any questions on how these work? And then you're going to start having homework ones, of course, that are secant cubed of negative 2 pi over 3 plus cosecant squared of pi over 3 minus cotangent squared of 330, and you're just going to be putting all of that together and adding and subtracting the numbers that you get at the end. Questions? Okay, second topic for today, we're going to learn another method for writing equations of perpendicular bisectors. So we need to remember that if two lines are perpendicular, they form 90 degrees, and what's the relationship of their slopes? Chloe, how are the slopes related? They are inverse and opposites. Take the reciprocal, turn it upside down, change whether it's positive or negative. So one's positive, one's negative, and the fractions are upside down. Also, if something bisects a segment, it cuts that segment in half. So it has to go through the midpoint of the segment. So we are going to start seeing problems that look like this. Find the equation of the perpendicular bisector of the line segment who has two endpoints that we give. So we've got those two endpoints. The segment with those endpoints is this. This problem wants the perpendicular bisector of that blue segment. So if it bisects it, it has to go through the midpoint. And if it is the perpendicular bisector, it needs to form a right angle. Now we need to find the equation of the red line. Now, there's another kind of problem that we've been doing a lot of in your homework sets. Does this picture look a lot like the picture that when we first started talking about finding a certain other kind of line, we got a picture that looked like that? Maybe or maybe not tilted. What does this remind you of in your current homework sets up to now? Use the, to find the equation of the line. That is, does that picture look exactly the same as pictures for use the locus definition method to find the equation of the line that is equidistant? So it's exactly the same line. The difference is what you're going to have to watch for is, does it say use the midpoint formula method, which is what we're going to talk about next, or does it say use the locus definition method? This first part they can say either way. Find the equation of the perpendicular bisector or find the equation of the line equidistant from. Does not matter which one they say, just that they're saying get the red line and not the blue line. So midpoint method means we need to find the midpoint. Then we need to use this fact and find the slope of the blue line, turn it upside down and change whether it is positive or negative so we can get the slope of the red line. Then we have the slope and it goes through the midpoint. Does the red line go through either of the original points? So we cannot plug either of these in when we're actually getting the line. We must use the midpoint and the perpendicular slope. So let's go through these steps. So first thing is we need to find the midpoint. So somebody remind me, how do I get the midpoint between those two given points? Jack. Just tell me what to write down.
8 minus 4, or plus 4 divided by 2, and then 6, and then negative 3 plus 2 divided by 2.
So we're getting the average x and the average y, so we add them and divide by 2. And so what does that mean my midpoint actually is going to be? Anna?
6, negative 1.
So there's our midpoint. Second step is to find the slope of the segment between the original 2 points. So the slope of that blue segment. So Aiden, help me get the slope between 4, 2 and 8, negative 3. Catalina, bail him out. Nice and loud so I can hear you. Say what now? How do I get the slope between these 2 points? Having this epidemic of not being able to think today. Who can help me with that? Sophie. And plug some numbers in for those x's and y's in there. So 2 minus the negative 3 becomes 2 plus 3 over 4 minus 8. So what does that equal? So we found the slope of the blue segment. To get the slope of the red one, the perpendicular one, what do I need to do? Or what will the perpendicular slope be? Elizabeth? Yep, so tell me what it's going to be. Turn it upside down, change it from negative to positive. So now I want the equation of the red line. The red line has this slope, 4/5, and the red line goes through this point. So I've got to use the midpoint, not the 4, 2 or the 8, negative 3. I'm done with those original points now. So now we need to use the midpoint and the perpendicular slope to find our equation, and we need to put it in the correct form. This problem wants slope-intercept form. So slope is m, y-intercept is b. So what's the formula that has an m and a b in it? So this one wants us to end up in y equals mx plus b. So let's just start off with y equals 4/5 x plus b. Let's plug in 6 negative 1/2 and see if we can figure out what b needs to be. So let's see, 24/5 equals negative 1/2. So 24/5 plus b equals negative 1/2. Check my arithmetic there. Does that look good? Okay, so now I need to get a common denominator. So minus 5/10 minus 48/10 will be b. So that is negative 53/10. So my equation is y equals 4/5 x minus 53/10. So any questions with that? As I was saying, pay attention to what method they say to use on those, because they can describe the lines either way. Okay, let me give you a little bit of a review question since we have a test coming up tomorrow.